Hi everyone, today we're going to start a new chapter on parallelograms. So let's get started. So let's start with a review for some symbols that you may or may not have forgotten since we just had holiday break. So I'm hoping that you still have all of these in your minds, but let's see this right here. This is congruence. This symbol is for parallel lines. This symbol right here is for perpendicular lines, also written with a little square there to show that the lines are perpendicular. This is angle A. Usually you use angle A, something like this when you're showing congruence. So like maybe angle A is congruent to angle B. The M angle A, the measure of angle A, is used when you're representing, let's say, a degree, like 60 degrees. RS is used when you're measuring a length of a segment, so like maybe 5 centimeters. Segment RS, we use segment RS when we are displaying a congruence to say, I don't know, AB. So to practice a few of these drawings, we have draw AB, ray AB, such that it bisects line segment CD. And so we can draw CD. What I'm looking for when I ask you to draw CD is to make sure that you have 2 points because those values are your C and D. I'm also looking that your ray AB does bisect meaning it cuts it in half. So I'm going to call that A. I am going to call that B. And that actually isn't completely done because if something is bisecting, it cuts it in half. So you do need to show that. The next thing I would do is to draw 2 congruent angles. So we're going to draw 2 angles that are congruent. Well, they're not necessarily congruent unless I actually show that they're congruent. So I'm going to show that with a little slash. I could have 1 slash, 2 slash, whatever I feel like on that. I also could put an angle measurement in there. So like I could say, I could do this and say that's angle 50 degrees. Well, if I did that, then I would need another, of course, angle 50 degrees. And now I can show that those are congruent. Now, those are both the same degree, but notice that I did not use the slashes for that. Draw line RS such that it's parallel to TV. Just keep in mind that when you're drawing your lines that are parallel, okay, here's R and here's S, and then I'm going to draw another parallel line, and that's point T, and here's point V. Now, these lines technically aren't parallel until I show that they are. So I'm going to show that they're parallel by putting lines like the little marks like that to show that they're parallel. Draw line XY such that it's perpendicular to WZ. So I'm going to draw a line WZ, and please make sure to put your points on. XY, so they're not saying it's perpendicular, so I don't actually have to make a line, they're not showing that it bisects it, but they are showing that it is perpendicular. Point, we have X here, and I'll put Y up here. I could put Y in the center here if I like. Okay, so quadrilaterals, here's the family tree of quadrilaterals. Quadrilaterals are shapes that have 4 sides. That's what they are, okay? And what's going to happen here is we're going to divide this into 3 parts. Quadrilaterals are parallelograms, trapezoids, and kites. Today, we're going to concentrate on parallelograms. The definition of a parallelogram is basically it's a quadrilateral that has both pairs of opposite sides parallel. So that's the definition of a parallelogram, is that it has both pairs of opposite sides parallel. Very important. Types of parallelograms are rectangles, squares, and rhombuses. And if they are all parallelograms, then that would conclude that all of them have both pairs of opposite sides parallel also. You have trapezoids, you have isosceles trapezoids. Isosceles trapezoids meaning two sides congruent. We're going to get into, in more detail, trapezoids and kites later on in the chapter for parallelograms. But today is all about parallelograms. So the definition of a parallelogram is a quadrilateral. So I'm going to write, this is really important. This is actually the definition of a parallelogram. And the definition, again, states that both pairs of opposite sides are parallel. For that to happen, it does have to be a quadrilateral. So a definition of the parallelogram says it's a quadrilateral with both pairs of opposite sides parallel, meaning that would be parallel to that, and that side would be parallel to this side. This side would be parallel to this side, and that side would be parallel to that side. You cannot just have one side parallel. You would need additional information for that to happen. But the definition of a parallelogram states both pairs of opposite sides are parallel. So you would have to have both pairs. Some theorems that are for parallelograms, very important. Opposite sides of a parallelogram are congruent. Well, we already know that both pairs of opposite sides are parallel, but now we know that opposite sides are also congruent. Okay, so all parallelograms have both pairs of opposite sides parallel and both pairs of opposite sides congruent. Opposite angles of a parallelogram are congruent. So if this shape ABCD is a parallelogram, then both pairs of opposite angles are congruent. And it basically means if this was, let's say, 50 degrees, then so would this angle be 50. That being said, if these are parallel, of course, these two angles in here are supplementary, and that would make that angle 130 degrees, because see how they're the same side? If I were to extend that, and this is my transversal, right? That makes that same side interior angles, and that makes them supplementary. In addition, if this angle is 30 and this is a parallelogram, then the opposite angle is also 30. The diagonals of a parallelogram bisect each other, which means that BD bisects AC. So BD cuts AC in half. So that segment is equal to that segment right there. It also means that AC cuts BD in half. Now, something that is actually really important is that they don't cut each other in equal parts unless it's like a rectangle or a square, but we'll get into that later. But what you do know by this theorem is that the diagonals bisect each other, which basically means it cuts each other in half. So we would have, if we had a parallelogram, again, I drew a new one, this and this side is equal to that side. Those little parts are equal, and this part here is equal to that part. The converse of the previous theorem, if the diagonals of a quadrilateral bisect each other, so they're saying if this is equal to this and that is equal to that, then this quadrilateral is a parallelogram. So is this true? Yes. So with both, but it have to be both pairs of the diagonals bisecting each other. If that's the case, it does make this a parallelogram, which means, definition of a parallelogram, both pairs of opposite sides are parallel. So proving parallel theorems, before we start doing that, I do want to review what we've gone over so far. Number one, we've gone over the definition of a parallelogram, which says both pairs of opposite sides are parallel. We've gone over also that both pairs of opposite sides of the quadrilateral are congruent. We've gone over both pairs of opposite angles are congruent, and we've gone over both diagonals bisect each other. Okay, all very important. There is one more that we haven't gone over yet, but I did want to introduce, and that was that if you have one pair of opposite sides, and they are parallel and congruent, then it is a parallelogram. And what that means is if I have a quadrilateral that has one pair of opposite sides that are parallel, and they're also congruent, that makes that a parallelogram. That makes this shape a parallelogram, that quadrilateral. And likewise, I could also draw it this way. And if I said this side is congruent to this side and parallel, one pair of opposite sides are parallel and congruent. That makes that a parallelogram. Now, we're going to start with this proof. It says ABCD is a parallelogram. AB is congruent to CD, so we know, this is what we're trying to prove. Now, by the definition of a parallelogram, that's telling me that AB is parallel to CD and AD is parallel to BC. That's what this does. That tells us, by the definition of parallelogram, it says that both pairs of opposite sides are parallel. So we know that ABCD is a parallelogram. Okay, so you would write your given ABCD is and we use this symbol a lot for parallelograms. That's given. Okay. Next, I want to see if you have noticed that I just gave you that these are parallelograms, but do you see this little line here, BD? Well, that's an auxiliary line. That's a line that I drew in. So I'm going to say draw in auxiliary line BD. And when I do that, that's definition of auxiliary lines. And that's going to allow me to prove, because what I'm trying to prove eventually is that this line segment AD is congruent to BC. And this line segment CD is congruent to AB. Well, I'm going to do that by proving that the big triangle here, ADB, is congruent to this triangle here, which is CBD. And so in doing that, if my lines are parallel, of course, that gives me alternate interior lines, alternate interior angles. And that makes 2 congruent to 3. So I'm going to write that down. Angle 2 is congruent to angle 3. We also know that angle 1 is congruent to angle 4. And we know that because alternate interior angles, if you have 2 parallel lines cut by a transversal, that's the line we just drew in, then the alternate interior angles are congruent. Okay. Number 4, once the alternate interior angles are congruent, we've got both of these are congruent to there. I think I'm going to say that BD is congruent to itself. So that's congruent to itself. And that would be the reflexive property of congruence. So I'll call that a POC. We know that, let's see, these 2 triangles are now congruent by angle side angle. So I'm going to say triangle ADB is congruent to triangle CBD. Make sure you be careful how you say those because they have to be in the right order. CBD by angle side angle. They have to be corresponding. So anyway, once the 2 triangles are congruent, then all the parts are congruent, which basically means AB is congruent to CD And also AD is congruent to BC. And that's if the triangles are congruent, then all the parts are congruent. So CPCTC. Cool. Oh, I would definitely write in the lines of reference. So that was from 5. This right here was from my alternate interior angles. So that's going to be 3 and 4. Reflexive, you can either say 2 or the drawing. The alternate interior angles are congruent. That's based on, I'm going to say 1 and 2. This is from my drawing or my construction, and this is from my drawing as well, or given. So there's the answers. So let's do a practice problem here, given some of the properties that we do know about parallelograms. So given that these two shapes are parallelograms, let's solve for x, y, and z. So what you do know is that opposite angles are congruent. So that means that y is going to equal 65. So let's put that in. Because it is a parallelogram, you know that opposite sides are parallel, which would make angle x also 65 because that's an alternate interior angle. Also, you would know that this right here is a straight line, and that adds up to be 180 degrees. So I could go 180 degrees minus 65 and get 115 degrees, which is now that angle. Well, that helps me. That's important because if this is a parallelogram, then both pairs of opposite angles are congruent. So z is 115. For this shape right here, what we do know is that if that's 56, so is x. So x is equal to 56 degrees. We also know that if this is 85, this is 85 because if it's a parallelogram, then these two lines are parallel, which gave me z and 85 the same. And you know what? Now I actually have a triangle. So I'm going to add 85 and 56, and I'm going to get 9, 14, 141. And if I were to subtract 180 minus 141 degrees, because remember, the sum of the angles in a triangle all add up to be 180 degrees, I'm going to get 39 degrees. So therefore, this is 39, which makes this another alternate interior angle because that's parallel to that. So we have y is equal to 39. I think I missed an angle. Oh, z. So here's z equals 85. Another example, we have 8. Now, if this is a parallelogram, then HM, we have that as 2x plus 5, and this is 4x minus 19. Well, if it's a parallelogram, then the diagonals bisect each other. So I can say that 2x plus 5 is equal to 4x minus 19. I'm going to subtract 2x. I get 2x equals, add 19. I get 24. So x is equal to 12. And I just want you to find x. In this problem, what do we know? We know 2 is 25. We know that Hij, this whole thing, is 120. And find angle 3. That's up here. Well, angle 3 is the same as this. So what we do know is if this is a parallelogram, then opposite sides are parallel. Well, if those are parallel, then that means that these two angles inside here are supplementary. So I can say 120 degrees plus, this is 3, so is this, so that's angle 3. The measure of angle 3 plus 25 is equal to 180. And then I have 120 plus 125, which makes 145 degrees, plus the measure of angle 3 is equal to 180. So I'm going to subtract 145 degrees from both sides. So subtract 145, and I end up getting the measure of angle 3 is equal to, borrow 7, what's that, 35 degrees? So we've got measure of angle 3 is equal to 35 degrees. For this problem, it says ABCD is a parallelogram. Uh-oh, this wasn't written right. C has to be here, and this has to be D. Your job is to prove that AE is congruent to CE, sorry about that, and BE is congruent to DE. So to prove that, okay, you would know, if you know it's a parallelogram, meaning both sides, opposite sides are parallel by the definition of a parallelogram, you know you're trying to prove this. So given that you have these angles, I mean, you can use alternate interior angles. We could say that angle 3 is congruent to angle 4, okay? We also actually know that angle 1 is congruent to angle 2. Additionally, if this is a parallelogram, then you also know that one pair of opposite sides are congruent and parallel. So that means that this side would have to be equal to this side. Well, if that's the case, then I can prove these two triangles on this side congruent by angle side, and therefore parts are going to be congruent if the segments are congruent. So the proof is here. You know, given that this is the wrong side, so this is C, this is D, so the values are going to be a little bit off. That's C and that's D. But aside from that, you'll get the idea. You've got your parallelogram theorem. The opposite sides are congruent. Vertical angle theorem, alternate interior angle theorem, angle side, and then the parts are congruent if the sides are congruent. If one pair of opposite sides of a quadrilateral are both congruent and parallel, so we have opposite sides are parallel and congruent, then this quadrilateral is a parallelogram. The reason being is if they're parallel, what you end up doing, just like in all the other proofs that we just did, was you end up proving that these triangles, this triangle here is congruent to this triangle here. And if that's the case, then all the parts are congruent. And if all the parts are congruent, then what you can say is that both pairs of opposite sides are congruent. It's a parallelogram if the opposite sides are both congruent and parallel. Well, if the opposite sides are congruent, check. We know it's a parallelogram. But also, if the parts are congruent, I can say these angles in here are are congruent, which makes them alternate interior angles, which would then make those parallel also. And therefore, if both pairs of opposite sides are parallel, by the definition, it has to be a parallelogram. So just a summary of what we have both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, both pairs of opposite angles are congruent, the diagonals bisect each other, and one pair of opposite sides are both congruent and parallel, both of those being biconditionals, the last two, 4 and 5. So a few more practice problems just before we go. Find x and y for the following quadrilateral. Find x and y if the following quadrilateral is a parallelogram, find x and y. Well, if it is a parallelogram, then you do know that the diagonals bisect each other. So you can say that 3y minus 8 is equal to y plus 12. Let's subtract y from both sides. I'm going to get 2y. I'm going to add 8 to both sides, and I'm going to get equals 20. I get y equals 20 divided by 2, which is 10. In addition to that, I know that 2x is equal to x. 2x is equal to x plus 9, and I'm going to subtract x. I'm going to get x is equal to 9. Okay. For this problem right here, we know that if this is equal to this, then z is equal to 9. We know that if this is a parallel, and it doesn't say that they're parallelograms, but we're assuming they are parallelograms, then y is 33 also. We also, and this is 50. If this is 11, that's 11. We also know that if this is a parallelogram, then opposite sides being parallel, these angles here are supplementary. So I could say that x plus 70 plus 50 plus 33 all adds up to be 180 degrees. So what I have is 70, 33, and 50 add up 3, 10, 15, 1. And I'm going to take 180 and I'm going to subtract 153. And I'm going to get 27 degrees. So x is equal to 27 degrees. For this bottom problem, we have opposite sides congruent. So that's 15. We know that's 8. So that's 8. We know that if that's 80 because opposite sides opposite angles are congruent. We also know that opposite sides, both pairs, are parallel. And what that means is if this is 80 here, then this has to add up to be 100 because if I extend these, then what that does is this becomes my transversal right here, and that makes those two angles supplementary. So if this is equal to 100, then this right here would have to be, y would have to be 70 degrees. For these problems here, again, if they are parallelograms, okay, if they are parallelograms, yes. If they are parallelograms, I would say that 3y is equal to 15 because that would mean opposite sides are congruent. And so y would equal 5. We also would say that 2x plus 8 is equal to 14. So 2x equals 6 and x equals 3. For this problem, it looks like these are both 40 because otherwise that would be too big of an angle. So those are both 40. It also means that this angle here is equal to this angle. So I can say that 6y plus 5 is equal to 35. 6y equals 30, so y is equal to 5. Well, if I plugged 5, well, I already know this is 35. Okay, so y is 5. What else do I know? That's 80. So that makes this here 100, because again, same reason as the other problem before. 100 minus 35. So if I subtract 35 from 100, borrow 9, I'm going to get 65. And let's see, where am I at? So if this is 65 and that is equal to, let's see here, 5x plus, 5x plus 35 is equal to 100. I subtracted 35. So I have 5x is equal, and I don't think you can see that. So 5x is equal to 65. So x is equal to divide by 5. So you're going to divide by 5. So you get 1. 5 goes into 6 one time. Subtract. You have 1 5 left over. So x is equal to 13. And lastly, we have a problem like this can be a little bit tricky. You know that the diagonals bisect each other, so you know that 2x plus 2y is equal to 18. You also know that opposite sides are congruent, so I also know that 2x plus 5y is equal to 30. And what I've decided to do is to subtract the quantities, and these are going to cancel. 2 minus 5 is negative 3y, and I have 18 minus 30, which is negative 12. So I end up getting y is equal to 4. I still have to find x. So I'm going to go back to my original equation, which says 2x plus 2y is 18. 2x plus 2 times 4 is 18. Well, 2 times 4 is 8. I'm going to subtract 8 from both sides. I get 2x is equal to 10, and x equals 5. Okay, so I hope that helps you regarding the lesson on parallelograms, and I'll see you next time. Thanks for watching.